Hey kids, it's me again, Mr. Lee, your science teacher, one of your STEM teachers. So we're gonna go over this today, the examples of ionic bonds. We're gonna do part two. So we already done salt, what me and Miss Daya feel when you guys don't turn in your work on time. Okay, so make sure you guys do that. Okay, so at the time of this video, I believe for block one, you owe me the periodic table. Oh, not sorry, not periodic table. The making the ionic compounds, and then block two and three, you guys owe me that too. But anyway, just take Canvas, check the due dates, check the due dates. I can't remember off the top of my head. I'm about to play Call of Duty, but I need to get this video in so we get part two done and part three done. Okay, so let's do magnesium and nitrogen. Okay, so this one here. Okay, this one's here because I noticed when you guys were working on this independently, you guys were kind of like low key like unsure what to do. What if it was a charge of like two and three? What's gonna happen? Well, it's actually simpler than it looks. So you just gotta remember a new tip is when you're writing ionic bonds is that the positive ion you write it first. You write it first in the formula. So for example, see how sodium here is positive and then chloride is negative. And then when you combine, and then you notice that sodium goes first, which was the positive, and then chlorine was the negative. That's right. And then you can see here with aluminum bromide. So aluminum here is that positive, and then bromide. So let me use another color to help you guys find the contrast. And then bromide was the negative. Same here. Negative oxygen goes last, and then you have the potassium, which is positive, is the one that's is the first one to go. So you always got to remember the positive ion is the first one you're gonna put when you're combining the elements to creating a compound. When you're naming or when you're classifying compounds. Okay. So let's try magnesium and nitrogen. Okay. So I have a magnesium ion. So it's Mg2 plus. So I now have a charge of 2 plus for Mg. And then for nitrogen, I have -3. So I have nitrogen and it's -3. So let me write that in another color. And then you have it in a -3, okay? So I'm going to close this off in parentheses. And then this is going to be a plus. And then I'm in purple. This is going to be a parentheses as well. So you're kind of asking yourself, well, it's a charge of 2, right? So what happens if it's a charge of 2 plus, but then the other one is a 3 negative? So here's what you guys are going to do. You're going to multiply it by, you're going to multiply the charge with a +2 by a 3. And then for the negative charge, the one that has a -3 or the charge that has, the charge that has -3, you're going to multiply this by 2. That's right. Because if you know 2 times 3 equals 6. That's right. So if I have a charge of 2 plus times 3, that gives me a positive charge of that gives me a charge of 6. And then if I was to add the orange for the nitrogen calculation, I would have a -6 because -3 times 2 equals -6. That's right. That's pretty much it. And then you get a net charge of 0, the total charge, and then that means you have 3 nitrogens. I mean 3 magnesiums. 3 magnesiums. I'm so sorry. 3 magnesiums and 2 nitrogens in this example. Okay. So I'm gonna underline it, and I ran out of time. I'm gonna have complete faith in you guys doing the last one with potassium and phosphorus at the bottom, because I only literally have 6 seconds to go, and I'm not paying for this. I am kind of poor, but actually I just want to spend money on this.